Welcome to my 6-part tutorial series to teach you how to use GameMaker to make a very simple platforming game. To give you an idea of what that game will look like, we can run it right here. It'll have a title screen, a start button, a sign system to teach players how to play the game, and those signs will change depending on how you remap the controls and settings later. Jumping mechanics, collisions, hazards like this that will cause the player to restart from a checkpoint. Wall jumping. Checkpoint system that saves your game. An attacking system. Room transitions. Visual effects like these scan lines and the glow effect that you see on the game screen. And also an auto tiling system to get like the level design to look like this. You can create your own auto tiles. If I hit escape, I can go back to the tile screen and go to the settings menu, and there's various difficulty options that I can toggle on and off. I can toggle the screen effects on and off, and I can also remap any of the buttons to be something different. So it's going to be a relatively robust but simple platformer game to teach you how to make platformers in GameMaker. So let's close out of this and let's get started. Download, install GameMaker. Once you get here, you're going to click New Project, Game, blank game. I'm going to call this Platformer Tutorial 2024. Let's go. Okay, before we even get started, a couple of things that I always want to remind people of. First, if you haven't watched my other tutorial series about learning GameMaker, which is a 3-part video series, be sure to watch that first. It's relatively simple, but it's just going to teach you the ins and outs of GameMaker first. And this series assumes you have already completed that tutorial series. Second, I wouldn't say I require, but I strongly recommend that you have a 3-button mouse. A 3-button mouse has a left click, a right click, and a scroll wheel that you can also click, because some of the shortcuts that we're going to be using in this game require that. Third, use a big monitor if you can. Right now, I actually have a 2-monitor setup, which is really nice for these tutorials, where you can put the tutorial on one monitor and use GameMaker in the other monitor. But if you don't have 2 monitors, definitely I recommend a very big monitor, and GameMaker is designed to utilize big monitor space. I do not recommend using a small laptop to use GameMaker. However, if you are using a laptop, do plug in a 3-button mouse still. Don't use a trackpad, because again, we're going to be using some shortcuts on the mouse. And if you're using a laptop, you'll see a little button up here that is where you can toggle laptop mode on and off. Laptop mode changes some of the shortcuts. We want to turn that off because you're going to be using a mouse, 3-button mouse. And with that, we can get started. We have a new project here. And first thing we're going to do is make sure that our target build is set to Mac, Windows, or Test. Either of those 3 are the exact same thing. Mine says Windows because I'm logged in right now, but yours should probably say Test. It's the same thing. And we are going to create some sprites and get making our game. So I actually have all the sprites created for you. You should be able to find a link somewhere, either in the video description or somewhere else, to download all of the art and sound assets for this game. Get them downloaded on your desktop and ready to go. I have them saved in a certain place in my computer, but save them where you can find them on your computer so you can very quickly start importing these assets. So first, we're going to create a new sprite. And I'm going to call this sprite S, lowercase s, capital P for player. And that's the format I'm going to follow with all of my asset names. Is there's going to be a lowercase letter or a lowercase series of letters followed by the actual name of the asset that starts with a capital letter. So when I say S player, you know that I'm talking about the sprite. And I'll stop saying capital or lowercase from now on. You should just assume that this is the format I'm doing. Lowercase s for sprite, capital P for player, S player. Go to import, and wherever you downloaded those assets, you need to import the player sprites, splayer0 through splayer3. So those are 4 images. Set the origin to be middle center. make sure the collision mask is full image, and the FPS should be changed to something like 6. I think that's what I have it here in my notes. And if you see me glancing over here, it's because I'm looking at my notes. So that is the correct animation speed. Very good. Now we're going to create an object. Call it lowercase o for object, then capital P for player, O player. Assign the sprite that you just created. And then we are going to rename the default room to R level 1 and change the size of that level to 896 pixels wide by 576 pixels high or tall. That's going to be the size of our game screen. We're going to click background under layers and select the color, and we're going to change the background color to something that's going to fit with our art assets later in the game. And since I have a custom color that I'm going to be using, I'm actually just going to put this in by myself. I'm going to use a hex color code right here. You're going to see hex, and you're going to put in 210021 and click OK. And it gives you a very, very dark purple. And then click your instances layer and drag in your player object somewhere in the middle of the room. So now let's start coding our player object. But before we do that, I always like to run the game, make sure I haven't induced any bugs. Yeah, there's our game window. There's our player, even though we can't do anything with that object yet. Open up OPlayer, and in the OPlayer step event, we're going to always do GML code, check don't ask again for this project. We're going to first get inputs from the player's keyboard. So write a new comment, get inputs. We're going to use some local variables. In this tutorial series, unlike my first tutorial series, in this one, I really try to adhere to a couple of rules when it comes to my programming, which is unless it's a variable that needs to be accessed before the step event runs, or if it's a variable that needs to get altered to adjust the way the game plays, I try to use local or temporary variables wherever I can. So let's create a new variable, var space, and then I start all my temporary or local variables with an underscore first, just as like a naming convention that I have. So var underscore key underscore left equals keyboard check vk left semicolon, and then another one, var key right equals keyboard check vk right. Keyboard check is a great function, which you should already know about, that checks to see if this key is currently being held down any given frame. So this will give us a variable that will be either 0 if it's not being pressed, or 1 if it is being pressed. And we can use 0 or 1 here. So now we'll write a new comment, get move direction, where -1 is left, 1 is right, and 0 is nothing. Var underscore dir for direction, but we're just going to call it dir, equals key, underscore key right minus underscore key left, semicolon. Give it a second to recognize that these are local variables that we've created, and they should highlight yellow. They just did. So what this will do is that if the right key is being held, it'll be 1, and the left key is not, it'll be 1 minus 0, so we get +1. If the left key is being held, but the right key isn't, it'll be 0 minus 1, so dir will be -1. And then if both keys are being held or neither key is being held, it'll be 0 minus 0 or 1 minus 1, which will both return 0. So that'll give us a direction. Now write new comment, get horizontal speed, negative left, positive means right. HSP, which the variable we're going to use for horizontal speed, HSP plus equals underscore dir times xl. So this will take our direction and multiply it by a variable that we're going to declare, and it'll make this make this value positive or negative. Positive if we want to move right, negative if we want to move left, and then assigns that number to our horizontal speed variable. And lastly, let's commit our HSP to the object's X position or horizontal position. So new comment, commit to movement x plus equals HSP. Now, as you recall from my first tutorial series, plus equals takes whatever value this is and then adds this value to it and then stores it again. It's the exact same thing as writing HSP equals HSP plus dir times XL. The exact same thing as this, but this is a little bit more sleek. So now we just need to declare HSP and XL, and you can either do that by going into variable definitions down here, but I like to do everything in a create event. It's a little simpler for me. So in the player objects create event, declare it, new comment, momentum, HSP equals 0, XL equals 0.5. Now let's test it out. So you can hold it left and right. You see it increases its speed and it maintains that momentum. And this is a momentum-based movement system. Now we need to be able to decelerate when we're not holding any of the keys. Now the reason we're using an acceleration or a momentum-based movement system is that it's just more realistic. In most modern platformers, they use a momentum-based system where you build up speed until you reach a maximum speed and then you decelerate. So now let's do our deceleration code. So before we commit to our horizontal movement, we're going to add a new comment, slow down character if no direction key is pressed. If underscore dir equals 0 with 2 equal signs, which is used to check the value of something. And this is the format I'm going to be using for conditions, a curly bracket in line with the condition, and then an ending curly bracket down here. It's what I did with my first tutorial series as well. And then indent, if HSP is less than 0, meaning we are, actually let me add a comment going left, and then else, which means we're going right. And up here, when dir equals 0, no direction key held. So now if we're going left, we need to slow down, or we're going right. Both, we just need to slow down in a different direction. So here, there's different ways to do this. This is the format that I use to reduce the value gradually until it hits 0 or until it hits a maximum value. I'm going to write HSP equals min, open parentheses, HSP plus decel, which is a variable we're going to declare, which is our deceleration, comma, 0, close parentheses, semicolon. And what this function does is that it takes the smaller of the, any of the values you include in separated by commas. So it'll take this value or this value, and whichever is smaller, it will make HSP equal that. So if HSP is currently negative, so say it's like -3. So we're going left and it's like at -3. It'll say -3 plus 0.5, which will now be -2.5 or 0, whichever is smaller. Well, the negative number is always smaller, so HSP will now be -2.5. And then it'll keep doing this now, -2 or 0, -2, -1.5 or 0, -1.5, until it gets to 0 and stop. Now the same thing over here, except it'll use max. HSP equals max, HSP minus decel, comma, or 0. Same thing, but the other direction. Now to set the max speed in either direction, HSP equals clamp. We're going to clamp the values to a maximum and a minimum. And the value we're going to clamp is HSP. And the values are going to be negative max underscore HSP, comma, max HSP. And this is another variable we need to declare. Close parentheses, semicolon, new comment, set the max speed. So this will make sure that HSP never gets smaller than negative max HSP or never bigger than max HSP, but we need to declare that variable. So let's go to create event and let's declare some variables. New comment, speeds. Max HSP, we're going to set it to 5. Maximum horizontal speed variable set to 5. And then under momentum, we are going to add decel equals 0.3. I'll add a new comment here, acceleration, deceleration. Now let's run the game and see if it works. Good, so it takes a little bit to reach our max speed, but then we reach it, and then we let go, and it takes just a little bit for our character to slow down and stop. Looks good. Now we're going to add some blocks for collisions, and we're going to add some gravity and a jumping mechanic. So let's create a new sprite for the block. Call this S block. We want it to be 64 by 64, which is already the default, and we want the origin to be top left, so that's the default also. We're going to edit the image, do the fill tool, and just set a bright color. I'm going to just do a bright fuchsia for now. So now we got to create an object, call it O block, set the sprite that we just created for it. Now go to our level 1 in the instances layer, click it, and we're going to make sure our grid size for our instances layer is set to 64 by 64. I'm actually going to make the color a little brighter. Click O block, and again, now this is where laptop mode and turning that off, make sure you have the 3-button mouse. This is one of those things. So first, if I'm moving this around, I'm clicking and holding the scroll wheel, and I can move the room around. To zoom in, I hold the control or command key and I scroll in, or I hold the control or command key and I scroll out. That allows me to zoom out. So this gives me fast movement and editing of the room. And also, if I highlight O block and hold down the Alt key, it allows me to paint using this object. So I'm just going to, also if I click away and hold down Shift, I can drag a box and select different objects and hit the delete key on my keyboard to delete them. But we are going to paint this object around the room. So we have something to collide. Let's add some varying heights because we're going to be testing jumping. Yeah, that looks good. And I'm going to move my character down here. Now let's code some collisions. So right now, if we run the game, we can move the character left and right, but it does not stop at the walls. And it doesn't have gravity or jumping yet. So let's fix that. In OPlayer step event, before we commit to horizontal movement, I'm going to write new comment, horizontal collision. Now this might seem a little complicated. I'm going to try to explain it the best I can. This collision code is going to be different than the collision code you learn in my first tutorial series. Because in my first tutorial series, the movement is not a momentum-based movement system. It's just very simple. But now that we're using a momentum-based movement system with acceleration and deceleration, which by necessity induces sub-pixel locations of our character, we have to alter our collision system to be a little bit more precise. So if it looks different compared to my last tutorial series, that is why. So we write if place underscore meeting, open parentheses, x plus HSP, comma, y, comma, O block, close parentheses, open curly bracket, close curly bracket. So first, it's going to check to see if in a given frame, if we move in the direction our horizontal speed wants us to move if we will overlap with a block object. And if so, we don't want that to happen. So we have to write some code to make sure it doesn't happen and that we stop. First, we're going to create a local variable var underscore x equals round open parentheses x close parentheses semicolon. So this will take the value of our x location and get rid of the subpixels. Now, because of our acceleration and deceleration being less than a full pixel amount, at any given point, the x location of the player object could be like 833.3, excuse me, or 100.4. And we need to get rid of that subpixel amount, so it's just a solid pixel, and we can just use the round function, which will round up or down, and it doesn't matter if it rounds up or down. And another variable var underscore pixel equals sign HSP, and this will take the direction we're going, whether it's a positive or negative value, and return -1 or +1 for pixel, and that's the direction we want to go to finally collide with the block. And now a while loop. While bang place underscore meeting. Now I say bang for exclamation point, which checks to see if the function is not true that we're going to give it. So if the place is not meeting, that's another way of phrasing it. So write an exclamation point, and I say for the rest of this tutorial series, I will use the word bang to describe that because that's what it is. In programming, it's called a bang. So bang place meeting, open parentheses, that local variable underscore x plus underscore pixel, comma y, comma o block, close parentheses, close parentheses. So first what it does is that it checks, hey, that new rounded x position plus whatever that pixel value is, -1 or +1, are we, and then it asks, are we overlapping with the block yet? If this does not overlap with the block, then do the following. Underscore x plus equals underscore pixel. So change underscore x by 1 pixel, and then it runs it again. Add 1 more pixel, whether it's negative or positive. Are we overlapping with the O block object? No, then add another pixel, and it keeps doing this until it overlaps. And if it overlaps, it does not add another pixel. And then after that, we write x equals underscore x. It takes whatever that last value is before we overlap with the block and assigns that to our x position or horizontal position, and then set our HSP to 0. And then we commit to the movement. So let's see if it works. Very good. The blocks now stop us nicely. Now we need to do the same thing for vertical collision, even though we have not added gravity yet, so we won't actually see anything, but since we're here, we might as well add it. It's going to be very simple. You can copy paste this and just change the values, but that's a very good chance of adding some unintended missed typos or bugs. So let's just write it out again. Vertical collision. I will go a little faster though. If place meeting x, y plus VSP, comma, O block, close parentheses, open curly bracket, close curly bracket, var underscore y equals round y, var underscore pixel equals sign VSP, while bang place meeting x underscore y plus underscore pixel, O block, close parentheses, underscore y plus equals underscore pixel, y equals underscore y, VSP equals 0. And then under commit to movement, we are going to write y plus equals VSP for vertical speed. However, in the create event, we still do need to declare this variable of VSP. So under HSP in the create event, add VSP equals 0. Now, I don't think there's any bugs in our code, but again, we can't test it yet until we get some gravity. So let's do that. We're going to add a comment before where the code calculates our horizontal movement, which is here. calculate horizontal movement. And then here we're going to add another comment, calculate vertical movement. And this is where we're going to figure out our vertical movement. So first comment, add gravity, VSP plus equals grav. Now we're going to declare the grav variable under speeds, grav equals 0.5. New comment, gravity. And also we're going to add a quick restart command so we can quickly test things in the game. So at the very bottom of our step event, I'm going to add a new comment called delete this before publishing and write if, scroll down a bit, if keyboard check pressed, VK, enter, close parentheses, open curly bracket, close curly bracket, game underscore restart, open close parentheses, semicolon. So I will just be able to hit the enter or return key and quickly restart the game. So now we have gravity, we can test our collision system. Yep, and we are stopping on the ground. We are not falling through the ground. That means our collision is working. Now let's add some jumping. In the get inputs section up here, let's add some new inputs. Var underscore key underscore jump equals keyboard underscore check, VK up. And then also var underscore key jump held equals keyboard. Oh, sorry, I messed up something. Where it says var key jump, this needs to be the function keyboard check pressed, not keyboard check. So var key jump equals keyboard check pressed. And then after that, var key jump held, keyboard check, VK up. Now, as you would know from my last tutorial series, keyboard check checks to see if the key is currently being held down, but keyboard check press just to see, checks to see if it was pressed the most recent frame. And then after that, if it's been pressed down already and it's currently being held, this no longer returns true. So it's great for a single keystroke. And we're going to use this to create a variable jump heights, where if you hold down the jump key, you go a little higher, or if you just tap it, you go a little lower, which is very common in a lot of platforming games. So to make sure that we can only jump if we're touching the floor, we need to add the following to our calculate vertical movement section. Underneath where we set gravity, we're going to add a new comment, ground jump. If, and there's going to be a lot of variables here we need to declare in the create event, if jump buffer is greater than 0, open curly bracket, close curly bracket. And I'm going to add a comment here, which is checks if the jump buffer is greater than 0. Jump buffer minus minus, which is another way of writing jump buffer minus equals 1. But we just do minus minus, or subtract, semicolon. New comment reduces jump buffer variable by 1 each step. So there we go. If underscore key underscore jump and 2 ampersand signs, VSP is greater than 0. So we have pressed the jump key and we are currently falling. So I'm going to add open curly bracket, close curly bracket, and I'm going to add a comment here to that effect. Jump key pressed, player not going up. We're going to write jump buffer equals 0. Set jump buffer to 0, can't jump again. And then underneath it, VSP equals jump height, semicolon, new comment, jump up. And then underneath all that, we'll write if underscore on ground, close parentheses, jump buffer equals 10. All right, so jump buffer, let me explain that really quick. What this is going to let us do is when we leave a platform, we're still going to be able to jump a little bit after walking off of a platform. That's also called coyote time in some platforming games, and it just makes it feel better to play. But for on ground, this is a local variable. We just want to make sure we're actually touching the ground. So we're going to go to the very top of the step event, above where it gets inputs, a new comment, and write calculate current status. And we're going to write var underscore on ground equals place meeting x comma y plus ground buffer comma o block. So this checks to see if we're within a certain amount of pixels of the ground, and if so, it counts us as being on the ground. Makes it feel a little better. We could just write +1 here to check if we're touching the ground, but it feels kind of awkward if you're doing repeated jumps, because sometimes you won't actually be touching the ground, but it feels like you should be touching the ground. And when you don't jump, the player's like, hey, what happened? This game glitched out. So we actually add a ground buffer to let players jump as if they're touching the ground, even though they're only a few pixels away. So go to the create event, new comment here. I'm going to call it jumping. We're going to declare those variables. Ground buffer equals 12. New comment, it lets us jump if we are at least 12 pixels close. Jump height equals -12. Jump height or jump speed variable. And then jump buffer equals 10. Frames after leaving. Oh, let me add the comment slashes. Frames after leaving ground when we can still jump. All right, so let's see if it works. Oh, we have an error, which is always good to have so we can see how I fix it. So variable jump buffer not set before reading it. Create line 14. Create line. Ah, there we go. That was the issue. I needed a semicolon. Missing semicolon. There we go. There was a missing semicolon there that was causing the issue. All right, so here. Should work now. And if on ground, jump buffer equals 10. Sorry about that. Sorry about that delay. I figured it out. So that's going to be very common when you're making a game, is finding like missing semicolons or typos like that. It takes some work, but you should be able to identify where it is happening, where it's giving you problems. So as you can see, I can now jump, which is good. But if I'm just tapping the jump button, I'm going the exact same height, but I want to be able to tap it to have a small jump or hold it to have a longer jump, which is easy enough to do. That's called a variable jump. So after our ground jump code, we're going to add a new comment called variable jump height and write if VSP is less than 0 and bang underscore key jump held, close parentheses, open curly bracket, close curly bracket. Here, I'll write a new comment. If going up and not holding jump, VSP equals max VSP, comma, jump height underscore min, close parentheses, semicolon, new comment, set jump height to be smaller. So this is this max function is working exactly the same as we have it up here, which is it just returns the bigger of the two numbers, whether it's VSP or jump height min. And we need to add a cap to how fast we can fall and rise, just as we did with horizontal movement. So let's add VSP equals clamp, VSP comma jump height comma grav max. So jump height is going to be our maximum speed going up anyway. So we're going to use that as the maximum upwards vertical amount. And for downwards vertical amount, we're just going to create a new variable called max gravity or grav max. So let's declare those variables under speeds. Let's write grav underscore max equals 12, maximum fall speed. Under jumping, jump height underscore min equals -3. That's the minimum jump height. Oh, I need comments there. Now we should have variable jumping. So if I tap it, I get a small jump. If I hold it, I get a longer jump. Little jumps. Now I want to show you the coyote time. So if I fall off this platform, I can still jump for a few frames. And also if I press jump when I'm really close to touching the ground, but not yet touching the ground, it still lets me jump, which feels more natural. So since this code is getting longer, let's start organizing it by creating some regions in our code, which is very nice in GameMaker. First up here, we're going to use this pound or number sign and then write region and then space, call this one current status. And then after this, we do a pound or number sign end region. And if you wait a moment, it's going to create a little minimizing button here. If I click that, it minimizes that. If I open it, I can open it and close it. That way we can keep it nice and organized. Under that, we'll create a region for inputs. End region. And that should be able to minimize then. And we're just going to do these for all of our sections. So here, I'm going to call this region horizontal movement. And put end region here. And then new region called vertical movement. End it here. Call this region collisions. Oh, and this needs to be called end region. There we go. This region collisions. Let's start minimizing these. So minimize, minimize. New collision, new region collisions. Then I'll put it down here. And region. And then I'm going to call this region remove before publishing and region. So now we can have concrete names for when we want to add code to different sections. We can just open up that section and then minimize it. So it's nice and clean. So for player animations, we want our player sprite to change depending on how we are moving in the game. So first we need to create a new sprite. Call it S player run with capital P and a capital R. Not import, go to, yes, import, find S player run 0 and import all of them all the way to S player run 3, which is 4 images. Set the origin to be middle center, set the frames per second to be 15. See how it looks? Yep, a little running animation. We're going to create another sprite called S player air. Import S player air, which should be right here. S player air 0, S player air 1, both of those. Origin to be middle center, and we're going to set the FPS to be 0. And this is super important. We need uniform collision masks for when our player object, even when it's changing sprites. So for S player, we set the collision mask to be the full image. For S player air, it can be slightly different. It can be a pixel off, whatever. So this is very simple. All we have to do is go to our O player object, and instead of setting the collision mask to be same as sprite, set it to be sprite's S player. So it will always keep the exact same collision mask even when it's changing sprites. And we have already set the collision mask of S player to be the full image. But even if you change the collision mask for S player, it will stay the same across all the sprites as long as you have this collision mask set to S player and not set to same as sprite. Okay, now we are going to go to our O player step event. We're going to go to collisions. We're actually going to create a new region after collisions. Call this one sprites. End region. And we're going to write image speed equals 1. New comment, 100% of animation speed. New comment, if moving, orient sprite according to direction of movement. So basically we want the sprite to face right if we're moving right and face left if we're moving left. So that's very easy, right? If HSP does not equal 0 or bang equals 0, image x scale equals sign HSP. So this gets the sign of HSP, whether it's positive or negative, it returns -1 or +1, and sets the image x scale, or the horizontal scaling. If it's +1, it's where the way it's supposed to be, which is facing right. And if it's -1, it flips the image the other direction, which is very useful for flipping sprites. And now, new condition, if bang on ground, so if we're not on the ground, open curly bracket, close curly bracket, if in the air, then also I will write else, open curly bracket, close curly bracket, if on the ground. So we want a different sprite for when we're jumping and falling than if we're on the ground, which we want it to be that running animation. So if in the air, we will write sprite index equals S player air, image speed equals 0, new comment, stop animation speed, make still image, and then image index equals open parentheses, VSP is greater than 0, close parentheses, semicolon. New comment, falling equals 1, everything else equals 0. So what this does is if we are falling, which means that our VSP is currently positive, this will return as true or 1 in GameMaker, and it'll set our image index to be 1. And this is our image index of 1. This is our image index of 0. So for falling, this is the sprite we want it to be. And when for everything else, we want it to be that if we're not on the ground. And then under else, here, if on the ground, we will write if HSP does not equal 0 or bang equals 0. Open curly bracket, close curly bracket, we'll add a comment. If moving left or right, sprite index equals S player run. Else, open curly bracket, close curly bracket, new comment, standing still, sprite index equals S player. Now we will test it out. So if I move left and right, I get that running animation and my character turns left and right as needed. This is my jumping sprite and falling sprite. That is correct. And when I don't move, it reverts back to just the stopped sort of breathing animation of the sprite. And that is it for this video. We've done everything we want for this video. We got some movement, we got some collisions, we got gravity, we have variable jumping, We have some animations. And we even got through a small issue with an error because of a typo, which is going to be something that you'll face in all of your game projects. So in the next video, we are going to add wall jumping, some enemies, we're going to add checkpoints, and some combat. So I look forward to seeing you there.